Chapter 2, Part 2, Solve using algebra, define a variable, write an equation, solve, and check. For number 2, this is a mixture problem. How many pounds of dark chocolate that costs $7.50 a pound must be mixed with 24 pounds of milk chocolate that costs $3.25 a pound to make a mixture that costs $4.50 per pound? So the trick is it tells us it's a mixture problem. So we're mixing dark chocolate with milk chocolate. I like to do this by drawing a picture. So we're going to try to get a mixture here of dark and milk chocolate. All right. And I like to put underneath, this is like a vat of dark chocolate, milk chocolate, and pouring it together, I'm going to have some mixture. I'm going to put underneath the cost per pound, and you could do this in dollars or in cents. I think it's easier to do it in cents, that way I don't have to use decimal points. So let's see, the dark chocolate costs $7.50 a pound, so I'm going to think of that as 750 cents a pound. You just have to be consistent. If you're going to do one thing in cents, you do everything in cents. The milk chocolate is $3.25 a pound, and the mixture is $4.50 a pound. First of all, it should make sense to you that the mixture price is somewhere in between the more expensive and the less expensive chocolate, which makes sense. It's not necessarily right in the middle. If it were, then we would just have even amounts of both. In fact, notice that it's closer to $3.25 a pound, so there's probably going to be more milk chocolate than dark chocolate. So there's a lot of things you might consider even before working the problem. How many pounds of dark chocolate? So we don't know how many pounds of dark chocolate, but we do know we're going to mix it with 24 pounds of milk chocolate. So what you know, you're going to fill in the blocks. We know there's 24 pounds of the milk chocolate. So I don't know what goes here. Let's use D to remember that's the variable we're using for dark chocolate. If you like to use X or N, that's fine, or C for chocolate. Anything is possible. Now we're mixing two containers and to get a large mixture, so I'm adding what is in each vat. So these vats represent how much chocolate is in there, not how much it costs. Not how much it costs for 1 pound or for all the pounds. The bottom number I'm writing underneath is the unit cost, how much it costs for each pound in that vat. So I'm pouring in D pounds of dark chocolate with 24 pounds of milk chocolate, so I have D plus 24 pounds of chocolate in this final mixture. All right, so then, now we're going to consider how much each vat costs. So I've got D pounds, and it's $7.50 a pound, so you have to multiply each pound by 750. So the cost is going to be 750D. So what I'm doing here is doing the total cost of each vat plus, so that's the amount it's going to cost for the dark chocolate. For the milk chocolate, I've got 24 pounds. Each pound is $3.25. Again, I got to multiply $3.25 for each pound, and there's 24 pounds, so that's $3.25 times 24. And in the mixture, I've got $4.50 for each pound, and I've got D plus 24 pounds, so I have to do 450 times D plus 24. So there's the equation. The picture is a way of defining the variables. Now, there are a lot of other ways you can define your variables and get the equation. You could use a chart, which is what a lot of people use. I like using the picture. All right, so we have 750D, and I have to multiply 325 times 24. You can get out your calculator. So 325 times 24 is 7,800. And then on the other side of the equal side, I need to do my distributive property. 450 times D is 450D. Plus 450 times 24, again, you could get out your calculator, that's 10,800. So now we need to get variables on one side and constants on the other. So let's subtract 450D from both sides. And if the variable's on the left, I need to also subtract 7,800 from both sides. All right, so what do I have over here? 300D equals 3,000. So we want to divide by the coefficient of 300. And D is, well, what would that be? The zeros would cancel. 30 over 3 is 10. So that represents what? That represents how many pounds of dark chocolate. So let's draw a picture again. So look at our original picture we had and we found out that D was 10. So if we want to draw that again, now that means we've got 10 in here, 24 in here, and so if you add it together, 10 and 24, you would get 34, right? Now, let's actually calculate the correct price and make sure this all works out. This was $7.50 a pound. This was $3.25 a pound. And the mixture was $4.50 a pound. So here's how we check. I'm buying 10 pounds at $7.50 a pound. That would be $75. You can get out a calculator and do that, although that one's pretty simple to do without a calculator. Now we've got 24 pounds, right, at $3.25 a pound. Again, you can get out your calculator and you get $78. So if you bought the dark chocolate and the milk chocolate separately, you mixed it together yourself, then you would have paid $75 for the dark chocolate, $78 for the milk chocolate, and that is a total of $153, right? Is that the same as buying all 34 pounds pre-mixed at $4.50 a pound? So you have to put that into the calculator. You have to do 34 times $4.50 a pound, and that gives you $153. So that's what you've got to check. It works out either way. So now, what's the question? How many pounds of dark chocolate should I use? So that's the answer to your question. Whoops. We're going to say use 10 pounds of dark chocolate. Or you might say mix 10 pounds of dark chocolate. All right, mixture problem. If you didn't get that the first time, go back, look at it carefully again, and try it on your own.